In this DeBacco University video, I'm going to be going over what formal charge is and how it relates to Lewis structures, as well as an example here so you can develop a better understanding for this concept. Alright, so formal charge estimates the charge an atom would have if all atoms shared electrons equally. The actual charge does involve electronegativity, and it gets a little bit more complicated. However, this is helpful when it comes to drawing and evaluating Lewis structures. So again, here's a formal charge looking at just a negative charge. Well, in actuality, due to electron distribution, there are partial negative charges on all of these hydrogens on the end here versus just one central negative charge. So again, we're taking into consideration here how these molecules are actually going to form their actual geometry or shape. So how does it relate to Lewis structures? Well, the assignment of electrons in Lewis structures, the lone pairs and bonding electrons are shown. These are key to calculating that formal charge. There's also structure validation, comparing different possible Lewis structures using formal charge, and the one with formal charges closest to zero, or approximately matching the accepted charge in the molecule or ion, is the most often correct. So again, a formal charge good bad range, we're looking for that 0 being ideal, plus or minus 1. Really don't want to be much beyond that. So we're looking at how it relates to Lewis structures. Well, it allows us to make predictions for stability. Structures with formal charges that match the electronegativity trends are more stable. Negative charge on more electronegative atoms. Resonance and delocalization. This helps identify which resonance structures contribute more to the overall hybrid. Check that you have the lowest formal charge possible for all atoms without violating the octet rule. Remember, that's making sure all of these atoms have 8 valence electrons. Keep in mind, hydrogen will be terminal and that only needs 2. So our valence electrons minus the half bonding electrons minus the lone pair electrons, basically how we're going through and to be calculating this formal charge. So an example here, if we look at carbon dioxide, carbon has 4 valence electrons, no lone pairs, and 4 bonds for a total of 8 electrons. So the formal charge on carbon equals 4 for its valence electrons, minus 0 for its lone pairs, and 4 bonds, which is essentially half times 8, which equals 0. Same applies to both oxygens, making the entire structure neutral and therefore balanced. So again, we're going through, we're looking at the valence electrons, the non-bonding valence electrons, the bonding electrons, and taking all of those into consideration to calculate our formal charge. And if it's 0, as in this case, or neutral, this ensures the entire structure is balanced and also very stable. And as we know, carbon dioxide is a very stable molecule. This is a way we can apply some math and looking at the structure to again make predictions about molecules using their formal charge.